Good morning, everyone. Thanks for coming. As Kyle mentioned, thank you to all the sponsors. I hope some of you checked out some of the sponsor area. I know a couple companies were talking about jobs and other hiring. I'm probably going to do the same thing at the end. But we actually have a lot to cover, so I'm now 2 minutes behind. Welcome to Reliable, Scalable, and Maintainable Systems. This is a quality software talk, which is what I generally talk about because it's kind of my passion. So we're going to kind of quickly work through these three pillars, right? The reliable, scalable, and maintainable pillars. We're going to focus on reliable and maintainable, but scalable does get its love, just not in the way you might think. So my name is George Frick. I'm a developer from Milwaukee, Wisconsin. I still live in Wisconsin. I don't have any intention to leave. I'm one of those developers who's very pro bring the developers back from the coasts to the Midwest for a great life here. I'm a cat lover. I like to do world travel with my wife. We're foodies. We like to go everywhere in the world and eat the food. This is me at Hawaii Volcano National Park with my wife. That's my new hat. I also run and I do a little autocross. I'm a principal architect with Invisia. For those of you who can see on camera, Invisia LLC. A little Superman reveal. We're based in Milwaukee, Chicago, and Madison. I've been with them for 8 years. I've gotten to work on a lot of great projects. I do a lot of user interface design, but at heart, I'm an architect. I work across a variety of languages and frameworks and industries. I'm currently an architect at Landmark Credit Union, where I'm helping develop a series of public and privately facing software as we kind of plan out their roadmaps for the future. This picture is me a minute or so later after the wind has taken my new hat forever. So these things happen, but even with that happening, it's great to think about getting back out there in the sun and the world. So let's get started. So this is not an introductory session, unfortunately. If you were hoping to get like the basics, that's not why we're here. We are going to review them though, so I'll put you on that path if that's where you need to go. But there are a lot of talks about the basics of quality. So we're going to review it. Once we reviewed, we're going to kind of go into what the three pillars mean to me. We're going to look at this question, what is software quality, right? And then we're going to look at an action plan because it's a lot of talks always focus on like write good software and be a good architect, but they don't really talk about things you can do. So I wanted to start by reviewing the basics, and that really because I just wanted to set those table stakes for everyone, right? What you want to do is get passing grades in all of this. And then you'll be able to build credibility within your organization. And then you can kind of give yourself that runway that you need so that you're not always being firefighters and you're actually able to work as a team and start being architects and really working on your solutions, right? Less firefighting, more solution. So let's review these concepts, right? First thing I would say, you're gonna notice at the bottom of a lot of my slides, there's gonna be references. I didn't come up with, there's already been plenty of geniuses who have come up with all this stuff. I'm just trying to bring the best of what I found to you, right? So there's a site, webdevchecklist.com, beautiful website. It'll give you a full checklist. It will include ADA. It is very important per our keynote. I would say take the WebDev checklist, make it your company's own, make it your personal own, right? Start from theirs, and if you think that one section is bad, don't use it. And if you think another section is great, expand it, and really have your internal checklist for how you guys build software well. And that kind of gets us into this checklist of the basics, right? We want to have source control, right? We want to make sure that we're storing our source code correctly. There are unfortunately still companies out there who are storing things in folders and making folder backups. It's 2020, really time that wasn't a discussion anymore. Have a good branching strategy. I'm not going to defend unit tests here today. This isn't a why you should unit test for those of you who think unit tests are bad or don't do them. There's also probably people here who go the opposite direction and do 100% code coverage. We're going to talk about that a little bit later, right? But the quick tips are, test your logic, not your framework. Don't end up testing Hibernate or testing Entity Framework, right? Make sure you have respectable code coverage. I usually target 80% with my clients. And then remember that you're testing to prevent regression. There's a large quality control there, right? Make sure you're linting, right? You want to get consistent formatting. You want to prevent errors. There's a lot of things about that linting do for you, especially if you're using a newer language like Go, where the linting is now kind of built in. It's going to format your code for you when you compile it, and so that it can make sure that it can upgrade your code between versions. And then even without that, you always want to be consistent for readability. We spend more of our time reading code than writing code. I think it's actually a 10-to-1 ratio of the time we spend reading code to writing code. Peer review is the big one here for me from the basics, right? It really helps you catch those silly mistakes. For me, what I find really helpful is when I make a pull request, the first thing I do is go over my own pull request myself. And that's that time where you find like, oh, wait, hold on, this is a draft, I have to fix that. It also lets you discuss structure and get consensus. And that's important when you have quite a few different people working on a code base, because you might both put in pull requests at the same time that have a similar structure. And it's nice to get that third-party person who can come in and say, hey, your guys' stuff looks similar. You should collaborate and get one pull request in with the shared code. So the peer review really helps with that. We're not going to do a big, long explanation of solid today, right? Single responsibility, open close principle, list off substitution principle, etc. We're not going to go into grasp or dry or the clean architecture onion, right? But those are all super important, and you should get those down. And then of course automation. You shouldn't be hand building your software. You shouldn't be hand testing your software. You should not be hand deploying your software. You shouldn't even be hand logging or doing any of that anymore, right? Like when something's wrong, you shouldn't be digging through logs. You should be searching through your logs with like seek or bug snag or have the elk stack set up. There should be something there so that when things are wrong, the data is coming to you. And so those are the basics. And unfortunately, we probably all can be looking at this list and thinking, well, we can do all of this and our software can still be really bad. It's very possible for us to do things like build the wrong software correctly. And then it's also possible to follow all these rules and then somehow you get to the end of the project and the software is terrible. And so that's kind of the beginning of our journey. How do we make better software? And these basics help with our code, but they don't necessarily help us have better software. So the first thing we want to do is align on what those pillars mean to everyone. For me, it's always very important that everyone in the group have alignment, which means that we all agree on our goal, right? Usually you'd have visibility come first, but that's a different talk. So what does it mean for a system to embody these three pillars? We'll start with Martin Fowler, right? I thus divide software quality attributes into external and internal. The distinction is that users can see what gives software systems high external quality, but they likely can't determine high internal quality. Software quality will always depend on who you ask. For example, what does software quality mean to your operations team, right? Is that going to mean it doesn't bring down their servers, that they don't have to constantly be standing up new servers? But let's not get ahead of ourselves. What kind of differences are there really? So again, this depends on who you ask. We can quickly see what a business user might expect, and it might not match up with what a developer expects. And I've been experimenting with this for over a year now. I've been interviewing people for jobs in Vizia. I've been working with other interviewees who are asking me for help because they're trying to interview at a company. I've been asking managers in meetings at my clients. And I even had a roundtable earlier this summer with some people around Wisconsin. And there's clearly a difference based on who you ask between what they think quality is, which is actually the same thing we experienced when we did that with UX the year before. But there's also great news here, right? So we can see that error-free is actually on both lists. Your external users expect your software to be error-free, which is where all those basics come from, right? They expect there not to be errors. But beyond that, they both have their own list of things they think are important. You know, if you're interviewing a developer and you say, what does software quality mean to you? It's very likely that the developer is going to say, well, the code needs to be readable, right? That's going to be that's what I have found to be the general thing that I hear from developers. But we've made progress, right? The business, operations, and programming disciplines have all made progress here. And the last note here is for external, a lot of these things actually roll up under user experience, right? If your client or your customer is expecting ADA, for them, that's gonna roll up under user experience. And that gets into the communication stuff we're gonna talk about. You really have to be careful when you're communicating with people to find out what they're meaning. So for the technical discipline, we're actually making a lot of progress setting clear quality expectations, right? We have all those basics, but we wanna get beyond them. And we're starting to have these clear technical paths as our discipline matures, right? We have this book as an example. It's Designing Data-Intensive Applications. It's one of my recommendations for all developers. And it sets a clear path for the types of decisions you need to make around the flow of data and how you store it, right? Martin Kleppman is going to walk you through making a simple database out of a log stream, basically appending to the end of a file, all the way through big data concepts, event streaming, all of it. So you can make good decisions. Because one size no longer fits all. There was a period where you could pick the most popular framework, right? If you were .NET, you could just go, or ASP MVC. And if you were Java, you could just be Struts or Spring, and you were ready to go. No one could fault you for your decisions, and you just built your software. But unfortunately, that get out of jail free card is gone, right? We have things like the CAP theorem now that we know about that force us to make good decisions, right? Even today for the conference, some of the job openings are for data warehouse people. And so that's a completely different way to look at how you're going to be building things. What about the business? So for the business discipline, we're also actually finally making progress, right? It used to be that the business and IT were kind of in an arms race together, and it usually resulted in terrible software. But we're actually getting to where we're starting to do really well. This book is my example for this, the Phoenix Project. It sets a clear path for good communications, leadership, and mutual respect, right? We're finally getting to where the business is trying to set us up for success instead of just sending demands over the wall. And that's still a lot, right? We haven't even allowed operations a seat at the table. They're supposed to secure the enterprise, right? They have laptops out in the wild, especially right now, right? They have to put the hardware everywhere. Meanwhile, we're asking for new databases, and we're asking for cloud credentials because someone wants something in the cloud, right? And then we're also doing on-premise servers still. And so they have all of those responsibilities. So what you build must be reliable to you, reliable to the business, and reliable to operations. You want to ensure that each of these pillars is standing on a strong foundation, and that before you build too much on that foundation, you improve that foundation. And that's kind of what we're here to talk about. We're here to talk about making sure that as you grow, you keep your foundation wider than your growth so that you're always well supported. But of course, we're looking at this from the technical perspective. So we're going to talk about taking action from a technical perspective. But you should always start from this sweet spot, which includes a lot of those basics. And it's going to include good communication. So that might be, I hope that wasn't stressful, right? That's basically me saying, hey, we have to do better. But you can do it. It's actually easy and fun. This is where the exciting part of our job comes in, right? This is where we do fun stuff. We do architecture and we build things. So what we need to start with is a team action plan. And later we'll discuss how these are all actual personal action plans as well, right? So here's your team action plan. And just like the web dev checklist, this is all optional, but I'm hoping it inspires you, especially the maturity model. And that's why it's bolded. It's the one thing I hope you can take away from this today. This idea of where are we and where are we going, and really applying the agile process internally, and not in a stressful way, not in like a you have to go to Scrum, you have to do backlog grooming way, but in like an iterative development way. Unfortunately, we're going to start with soft skills because it needs to be addressed. It is part of technical software quality is your soft skills. So why do I think soft skills are part of technical quality? Because I think that when you don't have the correct soft skills, you tend to make things someone else's problem, right? You need to take radical ownership of problems that arise from miscommunications, right? If someone didn't talk about ADA and it turned out to be important, you have to take radical responsibility to make accessibility a priority and get it done, right? So like reliable, right? You need to make your portion of the software reliable, but you also need to communicate to the other pillars what you need for your software to be reliable. If you never go to operations and say that you're going to need another server for your Elk stack, that is responsibility that you needed to take, even though that's theirs to work to do, right? Scalable, right? You might understand the scale of the business, but did you ask the business what their growth plan is? Even if they don't come to you and say, we have this growth plan for the future, that's still your responsibility to make sure that you can scale for what the business's plan is and that you can communicate that need to them and operations, right? Same thing with maintainable, right? How often does this business change? Hopefully you know this based on your field, right? Are you in healthcare? Are you in insurance? Are you in a mechanical industry where you're building parts and shipping them? But how often is the business going to really need you to change the software so that they can respond to industry changes? Because that's going to affect your maintainability. You might need to design your software less to scale and more to be quickly changed. So focus on listening and communicating instead of prescribing solutions. This is especially true for newer developers, right? You go to the meetings, you have your ideas, and I see people come out with things like, if only people would listen to me. That's a hard spot to be in when you're at that maturity point in your development. And the way to get there is to become a better listener. So this is just a reminder, right? Relationships help you, the relationships you build will affect your quality, right? Your credibility, for example, is going to be earned slowly, lost quickly, right? And then there's this important line that we're going to get to more when we talk about the personal stuff. Technical ability is not credibility. You can be an SQL master, you can be doing C# for 15 years, all of that. That does not mean that some manager in charge of some business problem is going to automatically give you credibility and listen to everything you say. And that's a rough thing to start to deal with, that you need to build a relationship with that person, and then they will come to you as you build credibility with them, and then your ideas will matter, right? And we can pull all these together, right? What am I hearing? Do you have other concerns? One of my favorite questions when sitting down with a user, I'll go to someone's cubicle, I'll watch them use the current software, and I will say, what would be the best case scenario here? And you'd be surprised how, like, some people will go into a nice, beautiful rant about the parts they love or the parts they hate. But make sure you get those other things, right? Make sure you're doing that communication. And of course, make sure you state your own needs to both the business and operations. So now that we've talked a little bit about communications, we can finally talk about this maturity model. I want to talk about creating one. So what is a maturity model? So for me, within our teams, a maturity model is basically a report card and a plan for how you organize and build your systems, right? You make a maturity model to measure, learn, and build a community of practice within your organization. And this acts as a foundation for increasing each pillar. If your software is not reliable, you can return to your maturity model for why. Not scalable, maturity model. Maintainable, maturity model. You can give yourself a stable starting point, and then you can avoid veering too far off and getting off balance. You can use this to iterate yourselves. And then when we add in the decision documents, you have a clear vision of your past, your present, and your future as a team and as an organization. There are pre-existing models you can use. You can go ahead and just Google maturity model and pick one from another industry and try to follow it. But I greatly advise that you make your own and have it be a living model that will work better for you. And let's kind of look at how these come together. So here's a simple example. And normally the maturity model for me is a pyramid, and everything starts at the bottom. So in this example, we would start with source code management down in the bottom left here. And we would see that we have a current grade of B-. We last graded it on October 2nd, right? We had a Friday morning meeting and we went over our maturity model, and we plan to revisit this one in January, right? What do we do, right? Before I get into the decision document example, I want to cover kind of building this thing, right? Before we get into the formal instructions, right? So this doesn't need to, if you're seeing this and you're getting scared, this doesn't need to be in Jira. This doesn't need to be overly formalized. When I say agile, I mean little a agile, as in you can kind of do this with what works for you. Even if it literally just starts off as a single document that says like, our source code management sucks and we need to fix it. That's a perfectly good first maturity model draft, right? I can't tell you what goes in these left-hand columns. Don't necessarily copy this. You might be more fine-grained, you might be less fine-grained. Different things are going to be important to you, and you need to do what's important to your organization, right? Another example here before we get into reading it, right? This gives individuals an appropriate place and time to voice their ideas and concerns, right? Why aren't we using containers? Well, that's an excellent topic for the next time we go over the maturity model, right? And then anyone can come to this document, like the version that we're currently using. We have a section called suggestions. And you just go down to the suggestions section in the wiki and you edit it and you say, I would like to talk about event streaming, right? And then it also helps with new developer roll-on, because it's a frequent problem when you're rolling on new developers. A new developer will roll in, they might come from another organization with a different tech stack or a different approach, which you can learn from. That's an important side topic, but not what we're talking about, right? This new developer is gonna be like, oh my God, why aren't you using Kafka? You should be using Kafka, right? And you're able to quickly refer to your maturity model and say, well, we discussed Kafka 2 months ago. We do want to use Kafka, but we have these other things that we've had to prioritize, and these are the decisions we made, and you can review those documents. But we'd be happy to talk about it again, right? And then you can bring it up at the next meeting, see if it's become more important or if you're more ready, right? And then you also get the business who comes in and says, hey, we want fancy text Y by fall. And this happens to companies, right? This happened with the cloud allower. People are like, hey, we want you in AWS by the 1st of the year. You need to be able to have something to refer back to say like, well, these are the things we can move to AWS. These are the things we can't. These are the problems we're going to have. Your maturity model will help with that, right? So we have this example, right? Like, hey, we're not building all of our services the same, and they aren't stored in a consistent version. So I don't really think we're making what could be referred to as reliable builds. So I think we're a C in CI, CD, and DevOps, right? I think we need help there. I think we need to improve, right? And then someone else might have had an idea, right? You have the new developer who comes and like, well, I think we should be containerizing, right? Docker would let us experiment with event streaming, right? Well, we should really improve our pipeline first. Let's plan to improve our builds and artifact storage right away. I'd like to be prepared to store Docker images consistently. And so now the team agrees that you're a C in DevOps and that you're going to revisit November 1st because you're going to try to fix some of your DevOps stuff this month so that you have that maturity that you need to build on top of this pyramid, right? These are foundations. We're not going to do containers until everything below it is mature enough to support it. And then finally, these grades do degrade over time. Your A in source code management will slowly become a B, will slowly become a C, because you're building these things on top of it, and you're going to require more and more advanced solutions. An easy example there, right, is let's say you're only a 3-person team. You're probably just going to get an A in source code management because everyone can just fix everything, right? As long as it's in Git, you're fine. But if you're a 10-person team, now you need a good branching strategy. You need to figure out how you're going to divide the projects up so people aren't stepping on each other. When you go up to 15, 20 people, you're probably going to need to change a little bit how you move source code through your system. You might need to split up into sub-teams and then have a plan for how you manage code that way, right? So then how do you do this, right? So step one, what does your current maturity consist of? You can just write this down on a sheet of paper or a whiteboard in a meeting, or you can make a spreadsheet, or you can make a wiki page. It's all up to you, right? Do you do SCM, logging? Make sure you get your basics at the bottom, the things that are important to your company. For example, some companies, compliance is going to be super important. You're going to have that down near the bottom. You're going to have to make sure you always have a high grade in it, or everything else is going to kind of fall apart on you, because someone's going to come through and make you change things, right? Linting, right? And then you get to ask yourselves, this is the fun part, right? How do you want to grow? Well, we want to do configuration management because we're starting to have 50 different microservices, which is great. We managed to do the microservice thing, but they all have static configurations and we need configuration management. We want to grow into that, right? And then grade your current model, right? Hey, our repository is clean, but we rebuild instead of promoting code. That was not a problem when we had 5 services. Now it is a problem. We need to be promoting, right? So we're going to be a B- in SCM. And then you can make that decision. Can we grow or do we need to improve? And you might be able to do a little bit of both. I know a lot of companies like to try to, but I discourage you from taking it too far, right? And so this ends up being very similar to backlog grooming, right? If your grades in SCM are terrible, then you might have to do something there in the near future while you wait before you start working on config management, right? So at the end of the day, this gives you visibility into your process. It allows you to align on your goals. And then it also allows the team to be committing to the future, right? You're not going to have some random developer off in their cubicle doing something different, I hope, because they committed to the maturity model and their role in it. This makes for reliable, scalable, and maintainable code because bugs, outages, missed requirements, any monolith type code can be put through this process, right? We know that this is hurting this process. And this model gives you something to refer back to and plan with. So that's a really large topic for trying to cover a lot of smaller topics, but I encourage you to give it a try. The maturity model, unfortunately, leads well into this bad habit that I wanted to address as part of this. And I think that this is affecting quality a lot of organizations. And it comes down to one thing to say: encourage responsibility over rigidity. And this is technical advice. Somebody is bound to make a mistake in your organization. They're going to do a bad merge. They're going to mess up a feature flag and it's going to go to prod turned on or not working, right? They're going to misunderstand the business requirements and the software's going to do the wrong thing. And often we try to handle this with this famous line: there should be a process in place, right? Someone goes, well, this wouldn't happen if we had a process. If we had a proper process here, this wouldn't happen. And then the team ends up making a 4-page wiki about what you're required to do to merge, right? And now no one can do it differently, even if the situation calls for it. And so for the team, you'll essentially continue to add a series of controls and roadblocks that slow you down in order to prevent small errors that are going to continue to happen anyways, right? You're never going to predict that next small error that's going to happen, right? And the Agile Manifesto tells us people over processes. And this is where that becomes really important. Instead of that wiki page about the expected merge process, just have a lunch and learn. Have everyone come together, have the person who's best with Git talk about how they use it, how they manage branches, how they manage pull requests, right? Share that knowledge. Have members of the team talk about how they use Git, and take the responsibility that a mistake was made and that we need to be better at how we do things, right? 2 people can be allowed to do something if they both have responsibility, right? They're allowed to make the decision, but they are responsible for the decision, right? We're starting to see this in some ways, right, where we let different people use different IDEs finally, right? Some people have Visual Studio, some people have VS Code. I use Rider or WebStorm or IntelliJ. Sorry, I use Rider or IntelliJ, right? And then our big example here is 100% code coverage, right? This is where that process took over and ruined things, right? Because the first thing people do with 100% code coverage is they start excluding code from the code coverage. They mark the top, they annotate the top, exclude from code coverage. Or they start testing getters and setters. And now they're really not being productive. They're really not they're not raising the quality of the software. They're meeting a metric that you set to have a process in place because somebody didn't write enough unit tests, right? It would have been far better to take that person who didn't write enough unit tests and say, hey man, we're not going to give you new stories on the board this week. You're going to write unit tests this week. It's cool, and we know you want to get better at it. We're going to help you out. Just spend some time writing unit tests. That way you're helping that person, you're improving your team, and you're not just adding some process that's going to eventually hurt the team. Oh wow, I only have till 11:15. I'm going to pick up the pace here. So cycle time compression. This slide is lifted from Go to 2020, the Asynchronous Enterprise by Brendan O'Leary. I encourage you to watch both of these videos. Cycle time compression is generally thought to be about deployment frequency and lead time, right? But it's actually also about mean time to recover and mean time between failures. We tend to fight this idea because all organizations tend to emphasize mean time between failures. Don't deploy until we're 100% sure the software is perfect, right? But it actually turns out, if you watch the Martin Fowler video and he goes over the math and the data for this, mean time to recovery is actually more important than mean time between failures. It's far better to get out there and find out what's wrong and fix it than it is to avoid finding out what's wrong and fixing it. So reduce your cycle times to increase response times to business needs. That will actually raise quality. Let's look more closely. So let's say you release once a year with 12 features, and on average, each feature has just one bug. You're still gonna have 12 bugs in that December release, and the credibility cost that goes with it, because now you have to work with the business to prioritize those bugs. You're not gonna fix them all in a day. You're gonna have to go through that whole rigmarole, right? And then if we go back for a moment, right? So now you're at that top orange circle, and you're trying to get to that next orange circle, right? And that's next orange circle still not necessarily where you were trying to get. Then you have your QA, right? Your QA has to test a year's worth of changes, right? You might be, well, they QA'd it throughout the year. Well, a proper QA, as soon as you make those additional changes in November, is going to retest everything, right? And then let's say you release those features, but now let's say you release those features over a year. You'll never have to prioritize those bugs, and you'll have an average of one bug a release, which you know is now prioritized. It's the bug you're going to fix quickly and move on. Your QA will thank you, right? Your QA is testing these releases as you go. Feature flags start to be possible. As you make these small releases, you can start to wrap future things in feature flags so that they're there but not working, right? So we can easily look at this and say, well, the larger the change, the more disruptive to users. We see this a lot on public websites, right? Like if Bank of America or any of the large banks completely changes their website, they're going to spend a week taking complaints. I can't find this button, right? More testing for a QA. Harder to roll back, right? Like if you're changing a bunch of tables over that year, you're not rolling back that code. You've committed to moving forward regardless of what's wrong. Or you've had to also write rollback scripts, which is another sign you might be doing too big of a release, right? More technical debt, and the less the business will trust it, because business users are also people, and they also use banking websites and Google and Gmail and all these other sites that when they change too much, they go, no, what you changed the software on me for? I loved feature X, I just wanted new feature Y. Right? And your business users are going to feel the same way. They don't want you to give them new software every year. They want you to fix what wasn't working right, remove what they weren't using, and add what they need. And then, of course, there's this, what if the business changes halfway through? A lot of people get a little bit indignant about this. They go, well, why did the business tell us to build this if they were just going to change their minds? Well, the business is driven by the industry. The industry may have changed, and they need to change with it, and they're relying on you to do that. Right? And then small steps require less coordination. This one is really easy, right? You have vendor A and B, you have your operations team, you have the business teams, right? You have your cloud vendor help team. The smaller your change, the less you have to coordinate between all of them. If you can make a small enough change that it's just for one vendor, now you don't have to have that other vendor involved in the coordination for that release. You can keep all of those steps small. And then a gentle reminder, I encourage researching this some more on your own. mean time to recovery is actually more important than mean time between failures. And that leads us to Greg Young. We're going to pass from Martin Fowler to Greg Young. How many of us have worked on a greenfield project and added features that nobody has ever used? That does include me. It even includes some sponsors here today. Right? Stop over engineering. And so we lower our cycle times, we make smaller changes, we have easier QA, less bugs, and we have better business response because nobody wants to spend 12 months building the wrong thing. So that gets us right into build the right thing. In the Greg Young talk that I linked, he gets pretty radical about it, but I still encourage you to watch it, right? And the general idea here is simple. Build a small piece of software, have the business use it, then iterate, right? In my experience working with clients, I've seen it become a theme in projects where people delay getting software into the hands of their users, and they find out too late which features won't be used, and worse, which required features are missing, right? We can't use this. So reduce your cycle times and then build the right thing. Use the reduced cycle times to do that, to steer the ship, right? You don't have to follow the agile process, but follow the agile manifesto, follow the guidance that's there, that even people who aren't doing agile are finding to be true, right? You can resist doing large refactors or rewrites. So, you know, the quick highlight topics here, right? The most maintainable feature is the one that does exactly what the business needed. You're not going to have to change it a lot, right? The most scalable software is the smallest software. Maybe the software you're building should have been 2 pieces of software, right? Does all of the reporting functionality need to be in the main piece of software, or can you have a piece of report, you know, right? Can you have a client that does reporting and a client that does the business process, that we can release them independently without interruption? And you can even release the reporting one after you release the first one. And then of course, the most reliable feature is the one you didn't build. If you can leave it out, it's beautiful. And that leads us to this idea of the rewrite. As a consultant, obviously I hear this all the time, right? We've decided we need to rewrite software X because it's terrible. Or we've decided we need to rewrite software Y because the code is not maintainable. And every time we touch it, it breaks, right? Here's a big tip here, right? You can take your monolith, right? You can put it in a Docker container or not. You can just put it on another VM, right? You can make 2 copies of it. You can copy the Git repo. And then in 1 copy of it, you can start to remove the UI elements, right? If it's an old MVC app, let's say it's an old Java Struts app even, or a Java Spring app, you can go ahead and you can take out those UI elements from 1 copy. And then on the other copy, you can start to take out those services, right? You can slowly say, oh, well, for this one service, we're going to call over to the other copy to get the data, right? And 1 copy slowly becomes your RESTful API or your GraphQL or your CQRS, right? And then the other copy slowly becomes your UI. And as those things get pulled apart, you can start to call your other services, and then your API can start to provide things to other services. You start to get that freedom, and it slowly breaks down. But you don't need to say we have this huge monolith and it's terrible and we're going to rewrite it, right? You don't necessarily have to do that, right? And we talked about that when we talked about cycle time compression. Large changes have an entire list of associated problems, whether it be greenfield or huge refactors, right? And sometimes you do have to rewrite the software, but you can use that original domain to learn, right? I had a project. We had a giant file. It was like a 5,000 line file. It was full of ifs. It's the programmer's nightmare, right? Where it's 1 giant file, it's 1 method, and there's just ifs in it. And they were using code folding to divide it up, right? So you'd hit the little plus thing to open up the comment that would open up all the code. And we just took all those ifs and we broke them up into functions, and we called it our alert checker system. And it's still not good. When you go and look at each alert checker, you're like, this is kind of bad. But we broke it up. Now we can add more, and we can start to fix each one individually and test. There was really no reason to just stop dead and rewrite those alert checkers. And then finally, if you find yourself doing a large refactor as a developer, as an individual developer, do it in a branch, and then set that branch aside. Start a new branch and bring over small refactors from that giant refactor, right? Your coworkers don't want to get a pull request that takes them 4 hours to look at because you rewrote a subsystem, right? How do you practice breaking that up? Break it up into those sub pull requests, bring over those changes slowly. Here's the new classes I want to add. Here's the new exceptions I want to add. Here's the new unit tests I'm adding, right? And then slowly over a period, your peers are able to review what you're doing, and you're able to break it up into a stream of working changes, which will help you with smaller releases. You'll get better at reaching your end goal through small changes, which gives you more chances to adjust, right? Also, I always pitch this idea of what if your new software, what if the first release was of the old software, right? You just start writing, just the same time and budget you were going to put into that rewrite, go ahead, start the new project, but start from that old software, right? You can take all the features that the user loved and keep them. So that's a lot of talking about team, right? And at the end there, we kind of got down into what you can do, right? Your personal action plan. And we're going to continue that here. And so now we're kind of at the micro level, and we were at the macro level before. And I should remind you that all of those team actions can be done at the micro level, right? You can sit down and do your own maturity model for your software or for yourself. That's actually what I've been doing, is I do a maturity model for my skill set. And then I go, oh, I don't know enough about Kubernetes and it keeps coming up. I probably need to learn a minimal so that I can continue to do software architecture while someone handles operations, right? So what are these specific actions that we can take as individuals? We're going to revisit the technical and communication skills. On a personal level, your communication skills are everything. When you have an idea for a business or technical solution, you are going to need to communicate it well, right? When the business wants a full rewrite, but you know that a series of feature releases would be better, that's where communication comes in, and credibility. And technical ability is not credibility. Focus on listening instead of prescribing. And don't get discouraged either. Especially for young developers, they can get very frustrated, right? You've gotten this education, you've gotten all this experience, you've been writing good, bug-free software, you've been doing your unit tests, everything is automated, but you still feel like people won't listen to you, or you go to the architecture meeting and you have your proposal for what the system should use, and everyone just kind of goes, what are you talking about, right? Don't get discouraged. Think about how you proposed your change, right? Write down what happened, revisit it, right? Focus small. Start to make small, high-quality changes so that you can make larger changes later. And do the same thing with communications. When you go to those meetings, don't make a giant architectural suggestion. Make small, high-quality suggestions, build credibility and communication skills, and work from there. And it's actually going to lead you to much, much better software because people are going to start to come to you. And so if you truly are, right, a technical expert, then when people come to you, you're going to be able to deliver better solutions to them because they trust you, right? Being able to do your best partially comes with trust, right? And then finally, keep in mind that sometimes you're going to have a great technical idea and it's terrible for the business. It doesn't matter if it's 10 times as good if it takes twice the budget, because they just don't need it. They just don't need that solution. And don't get discouraged by that either. It's okay. And that kind of brings me to vocabulary. And in interviewing people and in talking to clients and peers, this continues to come up. This is a pattern I've seen around. And you can't design a great domain model and build great software if you haven't learned the domain. And it turns out that as professionals, our domain is technical, right? So we need the vocabulary around our domain. Remember that technical work is your business. Whether you want to mentor, explain your idea for the architecture of the new software, your ability to speak within the domain is important for both the business and technical, right? Expand your vocabulary so that you can get the most out of your communication and technical skills, right? At the bottom of the slide, you see this quote, I don't really know the names of the patterns, but I have them all internalized. I've heard this in a dozen interviews now. And luckily, a lot of these people I've been able to work with and help them expand their vocabulary, and they're starting to be able to do technical writing, right? Like if you want to be able to write technical blogs, you're also going to need vocabulary. But this is not a good thing to fall back on because it's not going to get you anywhere. A business person doesn't want to explain a concept to you twice. If a business person explains what an O4R is, an out for repo, which means that the vehicle has been set out to get repossessed by someone, they don't want to explain that concept to you twice. You need to learn that term. That vocabulary is important. And it's the same thing with something like Docker or a container or a VM, right? A write-on change file system, you need to be able to have that in a conversation. So don't abandon these things and just make an excuse that, well, I know it, I use it, I just don't know what it's called. Learn what it's called so that you can teach, right? The best way to learn is to teach. And if you want to be able to mentor people, you're going to need to be able to do that. And so this isn't a huge one, but it can be. It can really be your opportunity. And that brings me to learning from others. Stack Overflow, Reddit, Hacker News, Slashdot, right? there is a better way to learn from others than finding their solutions, right? What are other companies in your sector doing, right? Are you insurance? What are other insurance companies doing? What does their tech stacks look like, right? What about outside your sector, right? What are banks doing? What about companies that are twice your size? If you're a small bank, what are giant banks doing, right? If you're a small manufacturer, what are giant manufacturers doing? What about companies with the same tech stack? Are you doing .NET Core plus React on Azure? Well, what are other companies experiencing who are deploying .NET Core and React to Azure, right? What does their code look like? There's a lot of code in GitHub you can read. What does their infrastructure look like? That's starting to be a shareable thing now, right? You have your Kubernetes, right? You have your Ansible and Chef and all those files. You're starting to be able to compare and contrast those and say, what's this company doing, right? Join the community, which I know I'm preaching to the choir. You're all here today on a Saturday morning. Normally this is a Tuesday afternoon or something and everyone has been sent by their employer, right? So you guys understand what I'm talking about. Join the community. It's actually gonna make your code far better. It might even save you a lot of time because you're gonna find more things you can just use instead of build. Hopefully my headset didn't just die.
Audio is still good. Although, appears you may not be able to hear us.
Sorry, I think Kyle, you said something?
Yep, yeah, we're still able to hear you.
Okay,
Just
good.
cut out for a second.
I accidentally hit the button. Right, so join the community. Wow, we're actually like screeching right into the end here beautifully. And then finally, this might be, if more technical people might have come to this talk for this, right? You can raise your solution quality. This is a very personal advice. If you're here for team stuff, you can adjust this to the team, but you can do a surprising amount of things in your code on your own and go beyond the basics to raise quality. I tried to get some examples here, right? One for reliable, one for scalable, one for maintainable, right? You want to make more reliable code for your organization. Personally, you want to set the example for reliable. Well, when you're calling a web service, make sure that you have retry, right? And if the organization decides to add retry through console or some external solution, you were simply ahead of the game and now you don't need your internal rewrite code, that's fine. But if you don't have any retries throughout the organization, you can add that to your code. For your code, you can look at your exception handling and say, what's going to happen to a developer who needs to fix this code when it inevitably breaks? Does the exception that I'm throwing go properly to a log stream or log analytics? Does the exception I'm throwing provide proper context around what happened here? And then you can build for scalable. The easiest way to scale is to simply build smaller things, right? When I said earlier, what if you built the reporting app as a separate app and then the workflows as a separate app? Those both scale better now, especially if you built separate APIs for them, because you can just deploy another copy, right? The smaller things are, the more scalable they are. And the more you can reuse them, because now that reporting app is the basis for reporting apps, right? Make sure your names and unit tests are self-documenting. I talked about this a little bit earlier, right? It actually turns out that we read about 10 times more than we write when it comes to code. We spend most of our time reading the code. So make sure that you have your ducks in a row. This is a really easy thing to forget because you were just writing a quick for loop and so you used X as your variable name. But I will reject your pull request. What is X? It'll just say what is X in the pull request. And then of course, stop building things that fail when something is missing. This is an important and fun one that you can start to get into, right? Your application starts up, it goes to connect to the database isn't there. What does it do? Well, it just goes down, your app just doesn't start, right? Well, don't do that. Here's an idea. When your app starts up, if it can't reach the database, if it can't reach RabbitMQ, if it can't reach another API, it just starts putting out to the log stream. I don't have a database, I'm waiting for it. When the database starts up, connect and go to work, right? Your app can be smarter now. You can do these things. And I encourage you to experiment with it, right? Go, hey, does my app fail without the database or does it wait for the database, right? And that's a much easier thing to explain to the business. The application's waiting for the database. The application's not down. You can even have a screen right on the app that says like, hey, we're sorry, this app is experiencing technical difficulties. You can use it as soon as everything is resolved, right? Your app can be really, really smart. And you can do that on a personal level. Your commits can include these things, right? And this ends up being like going to the gym, but for programming, right? a lot of us learn solid. You read clean architecture, you read clean code, and you go, well, I know solid. This gets back to the vocabulary thing, right? I know solid, but have you actually sat with code that you wrote and said, is this single responsibility? Is this list-off substitution, right? And you can practice. You can take a week out. You can say, what am I going to do this week? All my pull requests this week and everyone else's pull requests that I review, I'm going to look at them and I'm going to see if they are single responsibility. And it doesn't have to be perfect. And don't start annoying your coworkers by saying, like, this isn't single responsibility, pull request rejected, right? But use that to learn and go, oh, you know what? I just put 2 classes in one, or I just put 2 responsibilities in one method. I'm going to redo my pull request. I'm going to break that up. Now I can unit test better, and now it's smaller, right? Each piece is smaller. And so really spend the time, right? Take a week and say, this week I'm focusing on low coupling. And when I make a PR, I'll review my code and ask myself if it's highly coupled. You can even ask the team, right? You can say, do you guys think this is highly coupled? Do you guys think I did well here? As soon as you set that ego aside and approach it from that, you're going to start to be the technical expert on the team. Because people actually prefer the low ego over the technical expert, right? They're going to come to you because they feel comfortable talking to you. So that brings us to, I actually went over, that brings us to resources and next steps. I'll try to wrap up here. I have the slides available, including my slide notes with that short link. If that's hard, the 3KZ thing, you can just go to GitHub. So I put this RSM document on GitHub. It's 2 things. It's the links to the slides. It's the links to all the videos and things that I referenced in the slides. And then it's also a picture into how I do my own personal maturity model. So it's got documents I'm reading. It's got terms I'm trying to make sure that I learn so that I recognize when they come up in talks, right? Like, you don't want to be watching a talk and not know what some guy's talking about, right? And so this RSM document that I created, it's kind of a view into my process, and I wanted to share it as a resource. And so there's lots of videos and other links at the top of it. And then as you get down it, you're going to be like, does he really not know what these things mean? I want to make sure I really know what those things mean. And I think you can do the same thing for yourself. I will answer any questions in the Whova app. Obviously, you can reach out to me. And obviously, I encourage you to practice. Thanks, everyone, for attending. Thanks to CWITC. Thanks to all the sponsors. Obviously, thanks to Invisia for sending me a shirt in time for the conference and for being my awesome employer. I got this off Slides Carnival. That's where I got the slide deck. They have a lot of cool slide decks. I used it for free, so they get their shout out. You can reach me at george.frick@gmail.com or through the Whova app. You can find me on LinkedIn by searching. I think it's George Frick /in/George Frick. I look forward to talking to any of you about any of this. I love talking about this stuff. So thanks, and that's it for me.